Hey, welcome to the Explainer. Today we're going to break down a really powerful statistical tool. It's used everywhere, from figuring out home prices to predicting how well a product will sell. It's called multiple regression, and it's all about seeing the bigger picture. So let's start with a puzzle that I think we can all relate to. You ever look at your car insurance bill and just scratch your head? Your friend does a similar car but pays a totally different price. So what gives? Why do these premiums seem to vary so wildly? Okay, so to get to the bottom of this, we're going to look at some data. But you're going to see really quickly that just focusing on one piece of the puzzle at a time, like say how many years you've been driving, well, that just doesn't give us the whole story. Okay, so here's a peek at the data for few drivers. And right away, you can see it's kind of complicated, right? Take a look at that third driver down. Only 4 years of experience, but yikes, 6 violations. And their premium is a sky-high $194. Then look at the last driver. Tons of experience, 16 years. But that one little violation means their premium isn't as low as it could be. So yeah, it's clearly not just one thing. And that really gets to the heart of the issue. The thing we're trying to predict, in this case, the insurance premium, is what we call the dependent variable. And its value rarely depends on a single factor. Nope. It's influenced by multiple independent variables. And that's exactly why we need a tool that can juggle all of these influences at the same time. So how do we solve this thing? Well, if looking at one clue at a time isn't working, we need a better tool for our investigation. And that tool, it's called multiple regression. Think of it as the ultimate detective's toolkit for data. And all that really means is that multiple regression is a way to build a mathematical story. It describes the relationship between several different inputs, like driving experience and violations, and one single output, which for us is that monthly premium. Okay, I know formulas can look a little scary, but stick with me, this is way simpler than it looks. Just think of it like a recipe. Y is the final dish you're making, our premium. A is kind of like the base price. And then each X is an ingredient, like experience or violations. And that B right next to it, that's its weight. It tells us just how much that ingredient affects the final taste. So let's take that general recipe and apply it to our specific insurance puzzle. It looks something like this. We're building an equation where we start with a base amount, the constant, and then we adjust it up or down based on a driver's unique mix of experience and violations. Now, this is the really cool part. Those B values, the coefficients, they're kind of like magic. They let us isolate the impact of each ingredient all by itself. It's like having a set of dials where you can turn up driving experience by just 1 year and see exactly how it changes the premium, all while keeping the violation style completely still. It's super powerful. All right, the moment of truth. We fed our data into a statistical program. So, what did we find out? Let's decode the results. Okay, here's the output. It might look like a jumble of numbers, but don't worry, we're just going to zoom in on the most important parts. The answers we're looking for are right here under coefficients, and then we're going to look at this r² value down at the bottom. So what does this minus 2.75 number mean? Well, it's pretty simple, actually. It tells us that for every single extra year of driving experience you get, your premium goes down by about $2.75 a month. And that's assuming your driving record, the number of violations, stays exactly the same. And then there's the other side of the coin. For every driving violation you've had in the last 3 years, boom, your premium jumps up by about $16.11 a month. And again, that's holding your experience level completely constant. That's the penalty, measured in dollars and cents. And this brings us to r². You can think of this as our model's report card. And wow, did it get a good grade? 93.1%. That is huge. It means that just those two factors, driving experience and violations, can explain a whopping 93.1% of all the differences we see in insurance premiums. That little 6.9% leftover, that's just due to other random factors we didn't include in our model. But, like any powerful tool, multiple regression has some important rules you have to follow. Think of them as the rules of the road. Let's look at one assumption that we absolutely cannot ignore if we want our results to be reliable. It's a mouthful, I know, multicollinearity. But the idea behind it is actually pretty straightforward. Basically, the things you're using to make your prediction, your independent variables, they need to actually be independent from each other. You don't want them measuring the same underlying thing in two different ways. Here's a perfect example of what I mean. Our predictors, driving experience, and number of violations are great. They measure two totally different things. But imagine trying to predict someone's weight using both their height in feet and their height in inches. It's just redundant, right? You're telling the model the same information twice, just in a different unit, and that's just going to confuse it and make the results all wonky. All right, let's zoom out a bit, because in the real world, things can get even more interesting than our insurance example. Sometimes factors don't just add up. Sometimes they interact. So far, our insurance model has been what we call additive. The effect of one more year of experience was always the same, no matter what. But in the real world, variables can have a multiplicative effect. And that's where the magic, or sometimes the danger, really happens. It's when two factors combined create an impact that is way bigger or totally different than just adding them up. See that little extra bit on the end of the second formula? The part where x1 and x2 are multiplied together? That's the secret sauce. That's the interaction. This whole idea is called synergy, or an interaction effect, and it is everywhere. Think about medicine. A drug company might find two drugs that, when taken together, are way more powerful at fighting a disease than either one alone. That's a huge win. But they also have to watch out for the dark side of synergy, right? Where two drugs that are perfectly safe on their own suddenly become dangerous when you combine them. And that's the crucial takeaway here, you know? Understanding these interactions is absolutely vital. And it's not just about medicine. In marketing, it's figuring out how an ad campaign and a holiday season interact to create a massive sales boost. In finance, it's modeling how interest rates and inflation interact to affect the stock market. It's all about finding that hidden synergy. So, multiple regression, it's really more than just a formula. It's like a special pair of glasses that helps us see these hidden relationships all around us. It lets us move beyond simple one cause, one effect thinking to really understand the complex, interacting web of factors that are truly pulling the strings. Which leaves you with a pretty big question, doesn't it? What hidden connections are shaping your world?